I am dealing with students here, so I'll not go deep in technology, but will touch base on many things so that you guys will have an idea about what are the options in the industry and how you can make informed decision of what to use. Yeah, but before starting technical, I want to give a short intro about myself. Yeah, as ma'am said, I'm a BTech graduate from your nearby university, GNDU, and I graduated in year 2000. So I have 20 years of experience now instead of 15. And that was the year when, .com bubble burst and slowdown happened. And being an average student in the class, I didn't have a job also at that time. Yeah, then I joined a small company in Delhi, and then after 3 years, got job in Newgen, which is a mid-level company. While working in Newgen alongside, I completed my MS from BITS Pilani in 2006, and that's also in record time of 2 years. And best of all is without any supply. I mean, which was not the case in BTech through. So like I was mostly interested in playing, more than studies. And yes, I have played badminton at national level and selected for inter-university badminton also. And one more interesting thing is that I can play more than 12 games at very decent level. Yes, so definitely, if you are interested in fitness, you can contact me. I am always interested in coaching. As you can see, that's also my hobby. So overall, Gyan is, it is not necessary to be a top to go in big companies, and you can play and study both side by side. And definitely, physical and mental well-being both are equally important. Yeah, with that, now let's come to our boring topic again. Yeah, all good things begin with a story. So before I talk to you about serverless, I wanted to discuss some history of how apps have been built through the years and how that has led us to the computing options we have today. The evolution of platform. I will stop in between 4 questions. If you have any questions, please raise your hands. Yeah, definitely. I'm not sure whether I can see raising your hands, whether this app provides that or not. Yeah, but you can write in chat and I can figure out, or any moderator can just speak and I can answer that. Okay, let's move ahead. Yeah, before the arrival of the cloud, you have to buy your own hardware and software, then find someone to provision hardware, servers on the hardware, and application on those physical servers to run it in your own data center. Yes, you have to build your own data center to do something. And that was on-premise data center. Like you have to build physically on the premises. You have to deal with a multitude of questions, like number of servers, what physical security you need for your data center, the hardware failures and the software patching, backup, and who will monitor my app, and what is the right size of servers for my business needs. And there are so many of questions everybody has to look at before starting any of their business. So essentially a lot of questions, not all of which might be directly related to running specific business. For example, if you are running an insurance company, you want to spend your time growing and innovative in the insurance domain, not worrying about how to handle server and IT stuff. So along came the cloud and provided some relief from some of those questions, way faster than provisioning hardware, but still have questions about servers and scaling. Infrastructure as a service, like also called IaaS, is in the cloud, allowed you to forget about managing all the physical hardware. Instead of hosting it yourself, you could now utilize servers hosted by someone else. While the worries around managing physical infrastructure are gone, there are a number of questions that still needs to thought about. Sorry, I can hear a lot of background noise. If anybody can mute the participants.
Is it okay, sir?
Okay, still I can hear a lot of noise.
Since I have muted all the participants, I request all the participants to please mute themselves while the expert is talking. So you can ask your questions and queries in the last, or you can write in between in the chat box.
Thank you. Yeah, now it is okay. Great. So we are talking about IaaS in the cloud. So there are still number of questions that still needs to be thought about, even though we don't need to, manage the physical hardware. So how many virtual machines do I need? Because the IaaS is mainly based on the virtualization technology. So we used to get the virtual machines. How many would I need in future when my usage grows? Now, how to handle updating the servers for the latest security patches? And how to think about deploying my code and various dependencies such as application runtimes to the server. If a new version comes, how do I update my servers and all those things. And the other part is who monitors my apps and so on. So this means that you still haven't reached that ideal state where you could focus purely on your business and its problems. The cloud continues to help with that problem, and with the advent of platform as a service, also called PaaS. So there was even more simplification. PaaS allows you to just worry about your app and let the cloud vendor take care of not only the physical hardware, but also the ongoing management of the operating environment like operating system, virtual machines, or containers, as well as the various application runtimes, whether it is Java runtime or .NET, Node.js, and so on. You are not completely free from thinking about server software in this case also, since you still have to worry about how to scale your app and accordingly specify the number and size of the various compute resources your app would need at various times.
Okay, I'm really sorry to interrupt you, sir, but participants are asking to enlarge the screen, enlarge the slide screen.
Let me see, because I can see the full.
No, we are
Full
seeing
screen.
only the minimized version of your screens, and all the written part is on one side.
Okay, 1 minute, please.
Yes, it is fine now. You can maximize it now. Yes, sir.
What you can see now?
The full screen, sir, it is okay now.
Can you see this? There is one window also on that screen. Can you see that also?
No, there is no other window.
Okay, perfectly fine.
On your presentation.
Okay, 1 minute. Sorry about that. Okay, so I guess we were at PAS, right?
Yes, yes, yes.
Okay. In this case, still you have to, worry about how to scale your app and accordingly specify the number and the size of various compute resources your app would need at various times. So the latest in this series of evaluation is the serverless. With further abstract the under which further abstracts the underlying infrastructure from you and allows you to focus only on the single question. How are you going to build your app to achieve the best results for your business? And whatever it is that you are trying to do with your app. So whether it is the code to delight your customers through a great experience or the logic to communicate securely with the partner, that is where most organizations want to spend their time. And serverless allow you to do just that. Focus on your code and forget about the infrastructure. That is why everyone believe right now that it is the platform for next generation of apps. Now, before we jump into the explaining the benefits of serverless, let's call out what exactly it is not. It is not a total lack of servers, right? That would be a bit difficult. Like instead, it's a system where you don't have access to the servers at all, or you don't need to think about servers. For you, they're invisible, right? Not so long ago, all of the companies' IT systems were on-premise, right? And clouds were just white fluffy things in the sky. Like what I remember is clouds were of 4 colors: white, gray, black, and brown. Yeah, you may be wondering you haven't seen the brown clouds. So you need to go to Rajasthan to see those clouds. When there is a lot of sand in the clouds, you can see brown clouds too. Yeah, but now you can utilize clouds for nearly all of your systems and processes. Okay. So when we shifted to cloud, so there were new options which were put into play, and they started as a kind of spectrum. In the far left, we have a maximum control, and on the far right, we have a minimum maintenance. And we saw that in far left, we have an infrastructure as a service, right? Which were mainly the on-premise. We have full control of that. We have to build it from scratch and everything. Now we can continue down the spectrum and see the platform as a service. Even though before platform, there was a service software as a service. I haven't talked regarding that here, but I'll talk in the next slides. And to the far right, we have software as a service. So this is the software as a service, and in between those we have something called function as a service. So this function as a service is sometimes called as serverless. All right. Now let's look at everything at a single slide, and we'll see how all are different. Right. So this is the on-premise view where we had maximum control, and we have to do everything here. So you can look at the layers here. Starting from down, you see networking, storage, server, virtualization. These are the layers which you consider it as an hardware also, right? Then comes the next layer, which is OS, middleware, and runtime. So these are the 3 layers which you can consider as a software, or installation of patching of the software and all those things. And then comes the data layer, and then comes the application layer. So there are basically 4 layers: hardware, software, data, and application. This all needs to managed in on-premise by ourselves, like by the organization. Now, when we look at the IS, we gain the huge benefit of no longer having to manage underlying hardware. Right, all those 4 layers gone. We are not relying on our data centers anymore. And whether or not you are choosing Microsoft, Amazon, Google, Oracle, or any of the vendor to manage your cloud environment, you no longer have to manage that underlying hardware layer. However, you are still responsible for patching or updating OS, right? Managing the data updates by your application, and ultimately for the application layer as well. So still you have 3 layers to go. You have to manage in the infrastructure as a service. When we come to the next phase. So that is a PaaS, which is platform as a service. So we gain some additional capabilities because the platform is now not only going to manage the hardware layer, but also the operating system layer. So we still got a lot of flexibility to run our custom code because you own data, you own application layer, but we still have to manage because you have to own these two layers. Now, if you look at the next layer, which is at the far right, so this is the SaaS, which is software as a service. So there is nothing in this layer which you need to manage, right? Now with this approach, we gain the benefit of truly minimum maintenance, right? We said whether minimum maintenance we want or whether we want maximum control. So we truly we got the benefit of truly minimum maintenance because the platform is going to be managed all by all the layers, but this isn't running our custom code. So that means we are just using a service which is provided by somebody else, right? So now in between these two layers, when we say PaaS and SaaS, right, we get a new layer which is called FaaS, which is function as a service. So sometime this function as a service is also considered as a serverless compute. Now what this does is it gives some benefit of this layer gives a benefit of PaaS, where platform as a service. So we can see hardware layer and OS layer being managed for us. But in addition, we have a portion of data and application layer that are also managed. So instead of us having to manage runtime that runs our applications, in many cases as FAS, we can see that that is managed for us along with the process getting our code onto the correct server. So that means even in case of data and application layer, there is some part which is managed by the vendors. And there are some parts, for example, custom code, which was not flexible in software as a service. We can manage here. We can put our code here and we can use their infrastructure. So that is the flexibility we got in FAS. Now, why exactly we are talking about function as a service? Because as I said earlier, most of the serverless platforms take FAS approach for their compute workloads, right? However, it is more than just this. Serverless is not only the FAS. If someone tells you if serverless means FAS, that is incomplete because in addition to compute, when we are talking about serverless architecture, we are also looking at databases, file storages, as well as application messaging, data streaming, and API management. So there are many facets which comes with this. But FAS or function as a service is the core concept because that is how people are using in the compute workload. So mostly you will hear a lot of things, whenever you talk about serverless, you may hear, okay, is it FAS and vice versa. But that is not the only thing. Okay. Okay. So in a nutshell, these are the four main cloud abstractions, right? Software as a service, where it is self-serviced with zero operations. Then infrastructure as a service, where we say, agile on-demand infrastructure. Then platform as a service, where you have application-centric and integrated runtimes. So some additional capabilities. And function as a service, where pay-per-use code execution. It's a kind of whatever you are using, you have to pay. I'll come to that later. Though we have many more like these, right? Like CAS, which is container as a service, XAS, which is everything as a service. People are too innovative nowadays and can come up with many weird names. Okay. So okay, I'll stop here for a minute to see if there are any questions. Okay.
Sir, I think you can continue with the presentation. Participants may ask the questions at the end of the presentation.
Sure.
Yes.
Okay. So what does actually then serverless means? So first, let's look at some of the definitions provided by different people on the net. Right. Wikipedia. It says serverless computing is a cloud computing execution model in which the cloud provider runs the server and dynamically manages the allocation of machine resources. Yeah, that means developer no need to worry about managing infra or resources, and provider will do that for you. Perfect definition. The second from Tim Bray from AWS. If you can't see the servers in the service, then it's serverless. Yeah, that means servers are there, but invisible to you. The third one is Paul De Johnson. He is a CTO and strategist. A serverless solution is that which costs you nothing to run if nobody is using it. That's a perfect one. Means you no need to pay if anybody is not using your service. Why to pay for a dead service? By Simon Wardley, serverless is an event-driven, utility-based, stateless code execution environment in which you write code and consume services. This definition is, one of the complete one, as he highlight the event-driven nature of the serverless. I'll come to that somewhat later, and point out the importance of consuming other services in the serverless architecture. Right? It's not the function only; it has a lot of environment around it, which it needs to work with. As a standalone, it is nothing. Right. Then it's a David Tucker, which says a serverless architecture trades control and customization for increased development speed and reduced maintenance. We saw in the previous slides that regarding the maintenance and control. So that is what he's talking about. And Rachel Stephens says manage services that scale to zero. It's an idea of managed stacks. Right, somebody is running for me, so that means there are some different managed services which is around that, and somebody is running for me. For me, every managed services doesn't exist. I just say my function exists, that's it. So all of these are right, and all of these come together to form a picture. We'll see in further slides. Right, so in summary, serverless is abstraction of servers. Right, obviously still servers, everything running on silicon, but don't have to acknowledge the existence. The infrastructure and configuration of operating system and management of the server is all handled for me. Then second point is execution environment for single purpose function. So in earlier times, we used to think of a lot of things, the full architecture and the classes and all those kind of things. Here we are only worrying about a single purpose function. This is the one function, this is my logic, and that's it. I am worrying about that execution. I am not worrying about the other parts of the system. Then we have a runtime in a stateless container like Node.js, JavaScript, Go, Python, everything is handled automatically. This is a event driven, so what event driven means, that means there is some trigger for this, right? And as the trigger comes, then automatically this will trigger my function, right? So it's a trigger based auto scale kind of thing, right? And then the last part is micro billing. Yeah, instead of per hour, month billing, and all those kind of billing, we can say that it's a micro billing and it's a pay per use kind of thing. Right. So now let's look at some of the standards where we can see that when you say something as a serverless, so what does that mean? All right. So what you can call as a serverless. So first is the first point is speed of innovation over depth of customization. So what this means is, as an organization, one of the reasons to choose to embrace a serverless architecture is that we are not saying that we want to control everything, but we want to move quicker, which will help our digital innovation to happen faster. Okay. And the next point, like deferred risk over extensive ownership. So what we're saying here is that maintenance can be a risk for organization. So instead of choosing ourselves to have and own, maintain, let's say the OS, and make sure that they get patched, we are going to rely on serverless platform to do that for us. So we are choosing to have deferred risk. The next point, the cost of actual use or the cost of predicted use, right? Now, what this means is when we are leveraging the cloud, right? Ideally, we want to be sure that our cost maps to actual uses, which means we are paying for services as they are being used, right? Not if I have any service in the cloud, there is no customer and still paying for that. I don't want that kind of thing, right? Like earlier, with some aspects of the cloud-based infrastructure, we have to attempt to predict the amount of users, right? Key when I am starting my service, maybe I have hundreds of users, and as my business grows, I'll have more and more users, right? So sometimes we might be able to predict it accurate, but for most applications, that's simply not possible. So we wanted to make sure that our costs are tied to actual uses. Then we can consider it as in serverless. Next point is scalability. By default, scalability by design. Right. What this means is we want to be leveraging a platform, and when we don't have to configure a ton of different rules, uh, I don't want to create a rule where I say my CPU, whenever my CPU goes to 80%, you spawn a new instance. Yeah, that can be designed, right? And whenever it comes down from 50%, you can remove the instance. So those kind of things can be designed. That is scalability by design. So a team has to think about that and they have to choose, right? But we simply want scaling to be a first class citizen here, right? Within the platform. That meaning we don't have to think about it. It just does for us. Okay. And the last point is managed services or custom infrastructure. So what this means is if given a choice when building a custom application, when we are following a serverless architecture, we'll choose a managed service every time, right? Or something that we have to stand up, monitor and maintain. If I am trying to build an application, I don't want to think about authorization, authentication. Don't want to build my, database for those. So there are many services in the infrastructure which I should be able to use around that. I don't want to monitor what is happening, right? Whether my service is up and running. I don't want to build another monitoring system for my service. By default, when I'm using the serverless, that means a system or platform is doing that for me. Okay. look at some of the examples where serverless can be used. There are a lot of cases where it can be used, like 3-tier web apps, web APIs, for example. Instead of creating a VM, right, and putting IS on that. Hello? Hello?
Yes, yes, sir.
Okay.
Participants are again requested to please keep their mics off.
Okay. So in web APIs, for example, I don't want to, create a VM, then install IS on that. And, then I will deploy my service and then somebody can call it. It can just directly, I can just create a web API. I can write my logic there and say web API is already done. Nothing else needs to be, done here. Then that there are some data pipelines, batch processing, infrastructure automation. There are a lot of things like IoT sensors. So we have, this is like you have hardwares and all those things where they are sending, signals to the cloud, and you can just write the function which can just get all those messages and can just process that, just that one function, nothing else, right? So serverless is very, very powerful. Okay. We can use it for, mobile backends also, and specifically for the business logic. Yeah, there are a lot of examples we can use serverless in. So what does it mean? Can we use serverless everywhere? Definitely not. We have to look at challenges it has to understand it better, and then can make an informed decision on when to use serverless. Okay. So let's look at some of the challenges we serverless have. First, it needs a managed services. A function on its own, as I said earlier, isn't of much value. Right? If you need to build a lot of different services to use the function, then it's a useless for me. Right? That means I still need to install a lot of hardware, a lot of environment I have to build. So that means there are a lot of managed services given by the provider, and a function is using that. At alone, function as a alone is not as useful without managed services. Then traditionally we are having non-managed services. The architecture and all those things are using non-managed services. We cannot directly move applications from non-managed to managed or in the serverless. It will increase a lot of complexity. Here we have to think somewhat differently. So if we'll just directly move the architecture, it will be kind of lot of thousands of standalone functions, and it may increase the complexity a lot. So we have to think about what exactly we're trying to do. Then again, serverless is not equal to function as a service, right? And as like I said, traditionally non-managed services often is not optimized for serverless platforms. So we have to think differently. Now there is this challenge which is a limited lifetime of function. So instance of a function is short-lived. That means it has to quickly execute, and the code, whatever you are writing, it should quickly execute and just go away. It's a stateless. Right. So I am not sure about the how much time, but generally it shouldn't be more than 10 to 15 minutes max. But otherwise, it should be within some seconds it should finish. Then startup involves layers of lot of latency because it's a stateless. Whenever a call comes to the function is stored in somewhere in the storage and all that. So it has to bring from storage to front layers, and then it has to start, it has to execute the code. There are a lot of things in that. So definitely sometimes you can see it, runs within few seconds, and sometimes it takes some time also. So we have to think about the application, what exactly our application want to do, and based on whether it can handle whether it is okay to get the latency, to take the latency in the startup, then it is fine. Then if you're thinking of running the batch jobs, then it should conclude in a short time window. So that was the second challenge. The third is dependency on remote storage. Yeah, storage, that means it has to store somewhere. Storage may be from blob, cache, database, event brokers. There are a lot of, applications available, a lot of technology available, and that has to be in remote storage. A function in itself cannot store anything. Even a state of the function has to be stored externally. If we are thinking that our function are, kind of, maybe we are working on a workflow and it needs to work on some states, that state has to stored in externally and has to, computed by the function. Then, yeah, storage is slow, definitely. It's a normal hardware out right now for this, serverless. So need to write to slow storage and read back in every instance. So definitely there is a dependency on the remote storage for this. Then it is similar thing where IO perf and, generic hardware we have. Because right now all the functions, there can be thousands of functions, millions of functions which people are creating, so they are densely packed, and vendors are optimizing for that, and it needs share the same network, so it takes time. The input output perf and all those things matters here. Also they are using the same RAM, they are using the same processor power, and there is a limit there. You cannot say your function is a very powerful memory hogger or a processor hogger, and you can use the 100% of any of the processors, or you need tens of processor for your function. There is a limit exists for that, and we have to be make sure that we are if we want high those kind of things, then we should talk to platform vendors and make sure that that thing is automatically covered. Then this is another part where, because this is emerging technology and there are multiple vendors for this. I'll talk about that later. But vendor lock-in is possible because right now code is portable, because it's a function. It's a small function you have written, small logic you have written, and you can port it, right? Architecture always isn't. So what does that mean is it has a lot of infrastructure around it. For example, I want to log, right? Logging is needed. There is authentication and all those kind of things are there, right? You can port a code from one vendor to another, from Microsoft to Google, or from any vendors. But everybody is using different these mechanisms, right? Authentication is different across vendors and all those things. So it is difficult to port once a written code for a single vendor. And because value of FAS comes from the managed services itself, in itself it is nothing. So definitely we have to think regarding the where exactly I'm going, right? Which vendor I should choose. And as it's an emerging space, so definitely there is always a risk with picking the winner too early, because right now it's a lot of people are not using it. So it might be possible that today Microsoft has a lot of functionality, but tomorrow maybe Google will come up with something more, which is more aligning with the business you are in. So it will be always difficult to move from one vendor to another. All right, so these are the some of the challenges which we have to think before starting to work with the serverless. but it is a very quick and dirty way to start anything. For example, I am a small startup, or as a student also, I just want to try out some logic. Let's say I want to write some API. I can just quickly go write my code, whatever is in my mind, and that's it. Because authentication, you need a subscription for that. You can definitely go and authenticate yourself, right? By default you are authenticated, right? You want to see how exactly or how many users are using it. There is a telemetry exists in the platform. In any of the platform, you can see that how many people have hit your application. So that's a very quick and dirty way to try out anything with the customers or anybody. So if we yeah, in a nutshell, if you look at benefits and challenges in a single slide, yeah, reduces long-term maintenance, increase speed of maintenance, right? Reduction in required core competencies. So this is basically earlier we used to, think about all those things, the managed services, how I'll authenticate, whether my service is safe or not, whether anybody can hack it, or those kind of things I need to think. So that means instead of going deep into one thing, you have to increase your competencies, and you should know about all and each and everything around that also. Now you can focus specifically on a particular logic, right? Then definitely risk and compliance, you need to worry about that because vendor has to worry about that. And cost is tied to usage. If nobody is using it, definitely nobody is going to, you are not going to pay for it. If you look at the challenges, yeah, this approach is totally new, right? And it requires a new skills. We cannot apply the existing architecture we are thinking right now, right? Whatever the way we are thinking, that cannot be applied here. We have to think in very minute terms, in terms of functions, in terms of serverless, where we can say, yeah, this is very specifically logic. I mean, there can be let's say my application has something, uh, there is one particular logic which I want to use the machine learning, right? And Python is very good in machine learning, right? But the other way, I just want to use C sharp as my basic language, right? So definitely in this case, yeah, you can think that, yeah, when I'm going to that logic, I can write my function in Python, and then here I can write in C sharp, and both can connect and talk to each other because they can just do whatever is given to them. Otherwise, they have to pick everything from the outside. So the approach towards solution is different in this. Definitely, it means decreased flexibility and control across everything. Limited in compliance approach, if not supported in platform. Let's say if there is, I choose a platform which doesn't have a lot of compliance and security and all those things, then it will be problematic. I cannot add myself. All right, anybody, if there is a hole in the security, then anybody can call your function. It may be very difficult for you to stop it because vendor doesn't provide the security. And the last we just discussed is requires platform selection, like the vendor lock-in. Right. So yeah. So this is all about what exactly is the serverless, the benefit, the challenges, and yeah, everything. Now we talked about different platforms exist right now, like there are companies, Microsoft, Google, Oracle, like lot of companies are in this field. Okay, and lot has a different capabilities in this. So let's look at some of the capabilities of the main service, main platforms. Like first is Microsoft Azure Functions. So there are some kind of invocation models for that. Example, you can set you can have a scheduled where you can schedule, let's say once a day or once an hour, and can execute your function if you want. Right? Let's say you want to look at something and want to send a mail once a day to your team. You can do that. Right? It's just a quick and very dirty way to do that. You just need 1 to 2 hours for doing that. That's it. Then synchronous invocation method, which is like request response, HTTP. The third one is asynchronous way, which is event based. Something, for example, I have a queue. Whenever a message comes to the queue, the function will be invoked. Right. And then it's other way, the poll based, like in itself, function can poll for some things. Right. So if you look at Microsoft, so Microsoft had technologies, and even it provides the different outside technology also. Like these are the triggers, right? When you say blob storage, something comes in the blob. Cosmos DB, event grids, event hubs. So these are the technologies which are very scalable technologies, where you want to send millions, billions of messages. You can use event hubs, and you can use some functions which can auto scale to a very large, which can handle so large messages, that like millions of messages it can handle automatically. So these are some triggers, where HTTP, webhooks, IoT Hub, Kafka, which is outside of Microsoft, RabbitMQ, this is also outside of Microsoft. So these are some of the triggers which is provided by the Microsoft Azure functions, and it supports a lot of languages: Node, Java, C Sharp, right? JavaScript, Python, PowerShell. A lot of languages are supported in the functions. Okay, next one is AWS Lambda. It is called the Lambda functions. Invocation methods are same, right? Triggers, whatever is these are the Amazon infrastructure, where they have the API gateways, elastic load balancing. Simple storage. A lot of triggers are available from Amazon. So how the trigger works is, by default, platform provides that, okay, whenever you write a function, you can define what exactly trigger you want. So you can get a list of options there. Okay, these are the triggers I have, and I wanted to, let's say, trigger if any message comes to any of the queue. I just want to trigger. You can just select that in the UI, and that's it. Nothing else needs to done. Right. So there are very less supported languages, like only 4: Node, Java, C Sharp, and Python. Then third is Google Cloud Functions. It also has the similar kind of methods, and then it's a generic, like you have a HTTP storage, scheduler. Kind of similar triggers everywhere. The names are different because it's from the different vendors. And supported language is also like less, even though it doesn't have a C Sharp also, which a lot of people are using. So these are the three main vendors, right, for serverless. But we have a lot of other vendors, and even new startups are coming up in this field, like Cloudflare Workers, Alibaba Function Compute, IBM Cloud, Oracle Cloud. There are a lot of vendors there. There are a lot of functionality. You can go search in the net and even figure out those things, right? Okay, so now let's look at the how exactly organization, or what exactly are the standards which organizations are using, and how exactly organizations are using it. If you look at the full environment around serverless, or kind of which is called serverless, this is how organizations are using, like authentication and authorization. These are assumed to be a standard. If you are serverless, that means these are the by default things which you will provide me, right? Authentication and authorization, then logging framework. It's a kind of, whenever I write a log, by default, it will go in something, and you are providing me a tool where I can go and log in and just look at these logs, what exactly my function is doing. Then you provide a data storage, right? Infrastructure as a code, continuous delivery. So that is kind of a way to deliver your code continuously to the customers. It's a kind of pipeline where whenever you write something and let's say you have made that code to the production, but whenever you are changing, you wanted to deliver. Every day you wanted to put that in the production. So you need a continuous pipeline to, you build it, you deploy it, you test it, and everything is green, then you automatically deploy in the production. So that is kind of called continuous delivery. So that is also expected. And then monitoring, all right? How many, whether, how exactly I'm doing, whether how many customers are hitting my service. So these are the default things which exactly people are trying to, where organizations are looking into the serverless. So yeah, from my side, that is kind of at Uber level where I wanted you guys to think about serverless. If anybody talk to you about any logic or say, okay, can you actually do this? So I want you to think about these things. And these are the very generic terms which is used in the industry, where you can say, can I use IaaS, infrastructure as a service, or can I use PaaS, right? Can I use FaaS? So those are the things which should automatically ring a bell in your mind that yeah, I have heard something about that. Can I try out those things? So that was my goal, right? Just to make sure that you understand the technologies in the industry and how exactly people are using, what are the expectations in the industry. And if you have to think in a very quick way, then what exactly is the thing, what exactly is the technology you should think about. And you can also definitely try it, and because try at any point of time, because most of the vendors have some free subscriptions, right? Some like Microsoft has a 1 month free subscription, and for students I guess this is somewhat more they're giving. So yeah, so main takeaways from the serverless is, yeah, it's easy to develop and maintain, powerful and rich ecosystem, pay for only what you use, focus only on your code, nothing else. That's it. Thank you, guys. You can come out of your sleep. It was a good 45 minutes sleep, right? And all can wake up.
So,
Any
thank you,
questions?
sir, for your such an informative talk. And I think there are some questions in the chat box.
Okay, let me have a look. What is the scope of serverless architecture scope in future jobs? Okay. I see, if you're thinking about jobs particularly, right? If you look at the industry patterns, right? So I have shown you where exactly we were, where exactly we will be. Definitely at this point of time, we are, most of the companies are looking at the serverless because it is very cost effective and it is very quick way, right? Earlier, it used to be, if somebody give me a problem to work on, I take, at least a week to, think about everything and all that. But now it is so quick that I can say, okay, you have to try this. So within an hour or within half day, you can just try it out and say, yeah, this is how it works. So definitely this is a future. And but if you say, is there a jobs for the serverless? There is nothing called jobs for the serverless. It's a kind of, you need to be a domain expert. Serverless is just a way to think about that and how quickly you can do those things. So it's an addition thing which is like your competency. You can build it and say the same job I can do like this also. The same job I can do in the other way also. So that is where exactly serverless comes into picture. I hope that answers Piyush Agarwal's question. Okay, the second is, what are the consequences of serverless approach for operators? Ashwani Rathi. So Ashwani, can you just unmute and explain what does that means by consequences for the operators?
Ashwini, are you there? Yes, Ashwini, you can switch on your mic and you can ask what you really want to know.
Ashwini, what does that mean by consequences for the operators?
So, Ashwini.
Okay, seems like. Okay, I didn't understood this exact question, so I'll skip it. Whenever Ashwini is online, she can ask me, she or he, whoever he is. Right. And then third is, okay, I felt like quite a gap. How can we reduce it? What skills to learn? See, in computer science domain, right, or you can say branch, when you say we started, if you look at my, degree, we were using Pascal, right? And there is something called Fortran. You may not even heard of that, right? So technology changes every day, right? And in this domain, it's sorry, can you guys please mute when I'm answering? It's very difficult for me to concentrate. Yeah. So this gap will always remain, right? Doesn't matter whether, let's say, you graduate today, and if you look at after 6 months or after a year, this gap will definitely remain there. Because whenever new technologies comes up, people will start learning about that, but still the organization works in the old technologies. So you will always see that, yeah, there are, kind of gaps. The only guidance which I can give is definitely you should always look at the new technologies, and the important part is always try to work on that. Right? You see, okay, now today you understand that there is a function, as a platform is given. So I can write my logic. Let's say you just want to write a plus b is equal to, c, that function. You can just go and try it out. So that will build your skills. You understand the system, and you will say, yeah, I understand that, and now I can work on that. So that is one of the way you can, kind of fill the gap which you are thinking. But otherwise, yeah, you have to look at all, you have to learn a lot, and then definitely you can try out the things. Okay, yeah, I guess these are the only questions till now.
So,
Any other question?
participants, if you have any other queries and questions, you can write in the chat box. So, I think so there are no more questions or queries.
Sure.
So I thank you, sir, on behalf of the organizing team for such an informative talk, and it will definitely help our students and all the participants in the research book also. So thank you, thanks a lot, sir, and we will definitely come back to you again for such kind of more informative talks for our students. So thank you, sir. Thanks a lot.
Yeah, thank you, ma'am, for giving this opportunity, and thank you, students, for listening me, so patiently. Yeah, definitely, I could have slept if I, was a student at that time. Even in lectures, also, I used to sleep. All right, so don't worry.
The students, but the student nowadays are very, very alert, and they never sleep in the classes and never let their teachers sleep. Yeah.
Yeah.
Yeah. So
Okay.
thank you, sir.
Got it.
Thank you.
Thanks. Bye. Bye.
I thank you all the participants for joining for this webinar, and I would also request all of you to look forward for more webinars of this type. So thank you. Thanks a lot. Thank you all.